KNN stands for K-nearest neighbors classifier, and popularly used for binary as well as multi-class classification. In KNN abbreviation, K represents the number of neighbors of a given query. KNN is a supervised machine learning model. In case of supervised machine learning, the model learns from the labeled data set during the training phase. After the training is over, the model can predict the output to the unknown query, or input data set. The prediction accuracy depends upon the size and quality of the training data set. The training data set size should be large enough and should cover the extreme ranges on either side, along with the normal range. Further, the KNN classifier takes the labeled input data set for its training. The labeled data set is one that has input features, along with its associated class. For example, for number of students subjects marks as input features, and their respective results as label are presented here. Then, after completion of training of the model, the output is predicted by taking the user's query. As can be seen here, that 3 and 7 is the query, and that is not labeled in the input labeled data set. This type of query can be solved using the KNN classifier. Now, let's see how KNN model works. K is the number of neighbors of a given query. K can go from 1, 3, 5 and so on. It can be noted here, that K is always an odd number. The reason for K as an odd number will be discussed in subsequent discussion. Let's work out the example here. 4 students subjects marks along with their class or results are presented here. The results are treated as label and subject 1 and subject 2 are the input features. Hence, the labeled data set with 7 and 7 is class good. The labeled data set with 7 and 4 is class good. The labeled data set with 3 and 4 is class bad. And the labeled data set with 1 and 4 is class bad. And, finally, there is an unknown query 3 and 7. The KNN model is worked out here, to predict the class as either good, or bad. The input data and respective labels along with the query, are summarized here. Assume that the number of neighbors, that is, K is 3 here. Computation of square distance, between the query and the input features, is the primary step in KNN model. Here, the square distance between query and the data point S1, is computed. The formula is self-explanatory here. Similarly, the square distance between query and the data set point S2 is computed here. Same way, square distance between query and data set point S3. And finally, square distance between query and data set point S4 is computed here. Now, all the square distances are compiled in the given table. Rank formation is the next step in KNN model. Here the minimum square distance is ranked as 1. Then, next square distance, as rank 2. Further, the next square distance as 3, and, finally, the maximum square distance is ranked as 4. Ranks along with query and input features are compiled in a table here. Now, as the name KNN suggests, K number of nearest neighbors of query are identified using the ranks. Here, K is equal to 3, therefore, 3 number of nearest neighbors of query are identified. With rank equal to 1, S3 is the first neighbor of given query. Then, with rank of 2, S4 is the second neighbor, and with rank equal to 3, S1 is the third neighbor of the given query. Also, as K is 3, therefore, S2 is not the neighbor of query. Now, the ranks along with neighbors and input features are compiled in the table. The next step is to map the ranks with respective input labels. The rank 1 neighbor S3 is mapped as bad from input labels. The rank 2 neighbor S4 is mapped as bad from input labels. And, the rank 3 neighbor S1 is mapped as good from input labels. S2 can be left out, as it's not the neighbor. Now, it's time to query solving. The 3 neighbors' results are placed in a vector. Therefore, S3 with bad, S4 with bad, and S1 with good are placed in a vector. In the vector, it can be observed that the label bad is in majority over the good, by 2:1 vote counts. Therefore, as per the KNN model, the query 37 is predicted as the label bad. With K equal to 3, that is an odd number, a majority can be seen clearly. However, if k is an even number, then, there are chances of tie between the labels. And, in that case, there are likely chances of confused state of prediction. That is why, the k is always taken as an odd number in KNN model. Therefore, the final table with query label prediction is presented here. Hence, it can be seen that KNN is able to solve the given unlabeled query, to predict the appropriate labeled output. Here, is an example of implementation of KNN model in Python, using sklearn module. Here are few of the frequently asked questions on KNN model during interviews.